Welcome back, class. This is the new lecture, and here we are going to start the oxygen family. Previously, we had completed boron family, then carbon family, then nitrogen family. So, this is the oxygen family and 16th group, and after that, we have only one family left, that is the halogen family, 17th member. So, as per your syllabus, we will discuss the oxoacids of sulfur. In this particular lecture, we will discuss the oxoacids of sulfur. As we know that the oxygen family members are oxygen, sulfur, selenium, tellurium, and polonium. So here we are going to discuss about the oxoacids of sulfur, structure, oxidation state, and the acidic nature. So first, as we had already discussed the oxoacids of nitrogen and phosphorus, here we are talking about the oxoacids of sulfurs. But what is oxoacid actually? So oxoacids are basically the acids that contain oxygen. The acid that contain oxygen. And if video is no longer, then we will discuss the hydrogen peroxide also. If it is not longer, then we will discuss hydrogen peroxide also. Okay. So the acid that contain oxygen, it is called oxoacid. So for sulfur, the very first is the sulfurous acid. So how we will draw the structure of sulfurous acid? See, SOH, then SOH, and double bonded O, and with lone pair. So this is the lone pair. So the formula will be H2SO3. The oxidation state of sulfur here is +4, and the name is sulfurous acid. This is the sulfurous acid. Some other information we can gather from here is this sulfur is tetrahedral in geometry. Okay, 1 2 3 and 4. So it is tetrahedral and sp3 hybridized. In almost every oxoacids of sulfurs, the sulfur is in tetrahedral geometry. Okay, then in this case we have one S double bond O and two SOH bond. So this sometime in examination one may ask this question, that which type of bonding, because in next examples, next types of oxoacid, there are some SS bond also, SOS bond also. So that is why I need of this. Okay, so this is the sulfurous acid. Now moving ahead, second one, for sulfuric acid. So for the sulfuric acid, what will change? See, S with OH, no problem, then SOH, no problem, S double bonded with O, no problem, and this lone pair will be again converted with the double bond. So here the formula is H2SO4, oxidation state is +6, 1 2 3 4 5 6. Okay, and this is called sulfuric acid. This is sulfuric acid. So here we have two S bond, SO bond is 2 and 2 SOH bond. So this additional information, and again the the sulfur is in 1 2 3 4 tetrahedral geometry with sp3 hybridization. So this the additional information you can write here. Now the third one, the third is SOH, no problem with this. SOH, no problem with this. S double bonded with O. Okay, change is in this case, here S is doubly bonded with S, so this type of linkage is called thio. This is what thio linkage. When S is bonded with H, it is called thio. So here the formula is H2 S2O3, H2 S2O3, 1 2 3. So sulfur is in +2 oxygen state here. Okay, sulfur is in +2 oxygen state, and the name, as I told you, this is a thio linkage, so this will be thio because it is a derivative. One can say that it is a derivative of the sulfuric acid. So the form name is Thiosulfuric acid. So here we have one S double bond O, two SOH bond, and one is thio bond, S double bond S. That is why the name is Thiosulfuric acid. Okay, so here what change? The oxidation stage is quite different, as in +2 oxygen state. So this is one of the three types of oxoacid. Then moving ahead, like if you take the parent, the sulfuric acid. Okay, so two molecule of this sulfuric acid and removal of water molecule. Just remember the previous, the phosphoric acid, different phosphoric acid. So two molecule and removal of water molecule, two molecule and removal of water molecule. So what will happen here? Let's check it out. So S is double bonded O, then this double bonded O I'm writing here. Okay, S is double bonded O and this double bond I'm writing here. Then one OH, this one. Again the S is double bonded with O for two molecule, the second molecule. Then S is double bonded O, OH, and one H2 will remove, so one O is in linkage like this. Okay, so this is the di form of sulfuric acid. Okay, so this is the di form of sulfuric acid. Formula will be H2S2O7, H2S2O7, and the name of this compound is, two molecule removal of water will give pyro. Just remember in the previous video, pyrosulfuric acid, and another name of this is oleum. Point to be noted, oleum, OLEUM. Oleum is the another name of pyrosulfuric acid, and here sulfur is in +6 oxidation state. Here sulfur is in +6 oxidation state. Then again the type of bonding if we discuss. So type of bonding is very simple. 1 2 3 4 S double O bond, 2 SOH bond, and 1 SOS linkage. SOS. This is the difference thing with pyro. Okay, 2 SOH and 4 S double bonded. So this is types of bonding. So H2S2O7. This is not actually manufacturing process. I'm just making the structure convenient to you. Okay, these are not the manufacturing process, so you should remember that. So the two molecule with removal of one water will give you pyro. Okay, then what will happen with this if we add one oxygen here? In this case, if we add one oxygen, so let's check it out the structure here. So rest of this will be same, only one linkage will create here. So S double bonded with O, then S double bonded with O, OH, and here S is double bonded with O, S is double bonded with O, one OH, and this oxygen will link with another oxygen. So this is what the difference between these two, addition of one additional oxygen. So this will create a peroxide linkage. This is peroxide. I told you so many times, this is peroxide. So as the peroxide linkage is creating here, and with the addition of one oxygen, so the formula will be H2S2O8, and the name is, this is pyrosulfuric acid. Pyrosulfuric acid is what? The dimer of sulfuric acid. Okay, so this is also called disulfuric acid. Disulfuric acid. Okay, so this is another name of pyrosulfuric. So the disulfuric acid, so addition with one oxygen, this will give peroxodisulfuric acid. So the name is peroxo. Because of this peroxide linkage, the name is peroxo and disulfuric acid. Then the oxidation state. So if you go for the traditional method to calculate the oxidation number, here for hydrogen +2, and for 2 sulfur we required, and this is -16. So this will give S is +7, which is not actually possible. So as I told you, it is a peroxide linkage, so this will look like this: H2S2, 1 2 and 3. These three oxygen is bonded sulfur with direct, this 3 is also bonded with us, so H2S2O6, and this 2 is in peroxide form, so this 2 will be in peroxide form, so additional these 2 is required. Okay, so here +2, then +2s, this will be 12, and this will be 2, equals to 0. So S will be 12, 10, sorry, this 2 will cancel out this. So S will be +6 here. See, the oxidation state of sulfur is +6. So if you go with the traditional method, it look like 7, but it is actually +7. So this is wrong. S +6 is the oxidation state. Okay, then as here we had added one oxygen. If you adding an oxygen in this case also, okay, I'm writing, if you adding, okay, here, so what will happen? And one important thing you should remember, that the peroxodisulfuric acid, another name of this acid is Marshall acid. Sometimes the question asks directly with the name. Write the structure of Marshall acid. So Marshall acid, that is peroxodisulfuric acid. Okay. So here we have sulfuric acid, and then if we add plus oxygen, one oxygen here, what will happen with the structure? You can add one oxygen, so S is double bonded with O, then S is double bonded with O, one OH is there, and we can put one O in this way. Again it is what? The peroxide. So the formula here H2SO4. So what will happen here? Here it will be H2SO5, addition of one oxygen, and this is called peroxo. It is a sulfuric acid only, so it is peroxysulfuric acid, peroxosulfuric acid, or peroxomonosulfuric acid, you can say that, peroxosulfuric peroxosulfuric acid. And another name, as I told you, sometimes the question may ask, so another name is caro acid. Caro acid. Again we will go for the calculation of oxidation state. So here the oxidation state, again we have a peroxide linkage, so the formula will look like this: H2S, and 1 2 and 3 oxygen is directly connected, so O3, and O2 is the peroxide, so +2, then S, then -6, then -2 equals to 0. So here S is +6. So again the oxidation state of sulfur is +6 here. So here you can see that we have a different oxoacids of sulfur, and their oxidation state. Why I'm writing the oxidation state? Because this oxidation state will decide the acidic nature. Okay, higher the oxidation number, higher will be its strength. Now moving again with this thiosulfuric acid. Okay, so this thiosulfuric acid, or even we can go for this, if you remember, H2 H2S2O7. Okay, H2S2O7. So removal of one oxygen from here. If you remove one oxygen, what it will happen? This oxygen will remove. Okay, so if this oxygen will remove, the structure will look like this. So I am going to draw this structure here only. Here I am removing one oxygen from this. Okay, so the structure S double bond O, double bond O, OH, this oxygen will be removed. Okay, so here S is directly connected with S, double bond O, double bond O, and OH. So what will happen with the formula? Here the formula was H2S2O7. If I am removing one oxygen, so formula will be H2S2O6, and in this case the name is, here this is called thio. Okay, this is what? Thio. So this is dithionic acid. This is dithionic acid. And if you calculate the oxidation state of sulfur here, the 12, then the S will be +5. So again here the oxidation state is quite S is plus 5. There is one more structure we can draw. This is number 7. Okay, we can draw one more structure. This is dithionic acid. Okay, if you go for dithionous acid, dithionous acid, that is H2S2O4. So I am drawing the dithionous acid here. What is the structure? So here it this I need to draw in one paper, that is why I'm drawing here, because it will give you the whole idea to you know. So this is H2S2O6. By the removal of 2 oxygen, this is minus 2O. So what will happen? The structure is S double bond O, then S double bond O, then this will give you OH and OH. So the formula will be, by removal of 2 oxygen with this, the formula is H2S2O4. And here if you calculate the oxygen state, this will give S equals to plus 3. So this is again a different oxygen state. So you should remember that every time whenever we are going for the thiosulfuric acid, like this is dithionic acid, S is plus 5. This is dithionous acid. The name is dithionous acid. I am adding here. This is dithionous acid. Dithionous acid. S is plus 3. Then the thiosulfuric acid, S is plus 2. Okay, and one more I'm writing. One more is there, that is the 9th one, and this is S double bond O, S double bond O with OH, then one S, then second S, and then first double bond O, OH. This is another type of acid I'm writing. So here the formula is H2S4O6. So here we have 4 linkage of sulfur, that is the thio group. So it is called tetrathionic acid. And again, if you go for the traditional method of the calculation of oxygen state, the oxygen state will be plus 2 for this, and this is 4s minus 12, this will give you 0. So 4s equals to 10, so S is 2.5. So it is not 2.5 for every. Each sulfur is not equally contributed. Why? See, here oxygen is in minus 2, here oxygen is in minus 2, here oxygen is minus 2, and hydrogen in plus 1. So 2, 2, 6 and plus 1, this will give this sulfur is plus 5, and similarly with this sulfur is plus 5. So these two sulfur will contribute with S equals to plus 5, and whereas these two sulfur is contributed 0. Okay, so this is how the distribution will takes place. So this is again a different oxidation state if it is plus 5 2. So these are the different structure, oxidation state, their geometry of oxoacids of sulfur. After that, we will go for the sulfur electronic configuration, because that is very important actually. Why this different oxidation state takes place? Okay, as you can see that in this case we have +4, in this case we have +6, in this case we have +2, then we have +5 also, we have +6, +6, +3, +5, +6. So the different oxidation state. So how this will happen? So sulfur is in 16, so it will be 1s2, 2s2, 2p6, 3s2 and 3p4. So we will write the last electronic cell, that is the 3s2 and 3p4, and this is 3d. So this is 3s, 3p and 3d. So sulfur 16 at ground state, 1 2 3 4, and this is the vacant. Then we will go for the first excited state. The first excited state. What will happen with the first excited state? One of the electron from P will jump to D here. 1 2 3, 1 and 2. So this is the first excited state. Then the second excited state. So the second excited state. What will happen in this case? In this case, because they all are in same energy level, so the electronic excitation will be easy, as sorry, third energy level and the third energy level. So the electronic excitation can take place very easily. So what will happen in this case? One more electron from S will jump to D orbital. So here we have one electron, here we have three electron, here we have two electron. So what will happen here? Here the oxidation state will be +2 because we have two lone unpaired electron. Here the oxidation state will be 3 and 4, and here the oxidation will be +6. So what does it mean? It means sulfur can vary in oxidation state. It may form +2, it may form +4, it may form +6 also. So that is why the reason that we have a different oxidation state of +4, +6, +6, 5 is also is there, 2 is there. So this is what the reason behind this. And all thio group or all thiosulfuric acid has a different oxidation state. As you can see that these three oxidation states not belongs to thio. This is the dithionic acid. Okay, so it shows +3. This is the dithionic acid, it shows +5. This is the tetrathionic acid is showing +5. Actually is S is 2.5, but it is +5. So this is thiosulfuric, it shows +2. This is only, it shows the +2. So all most of the thiosulfuric acid do not show the actual or the real valency of the oxidation state of the sulfur. So this is what the oxoacids of sulfur. We will quickly complete the next topic also, because this is the only topic left in this oxygen family. It is not in much detail, so I will just complete in quick session. Be with me. And the topic is hydrogen peroxide. Hydrogen peroxide. So what hydrogen peroxide says? Hydrogen peroxide, here we have to discuss the structure first, then some properties, and then uses. So we'll discuss the structure first. So structure of hydrogen peroxide, oxygen, then the oxygen, another oxygen, then we have hydrogen here, then hydrogen here. This is how you can draw the structure. Okay, this is 90.2 degree, this is 145.8. Values no need to remember, I'm just writing. If you can remember, it is good. 101.9 degree, this is again the bond angle, this bond angle. So this is how the structure of hydrogen peroxide looks like. So some of the structural information, first is non-planar. Okay, it is in a non-planar. As you can see that hydrogen, oxygen here, 1 2 3 4, so it's sp3 hybridized, so it is non-planar. Then it is an open book structure. Open book look like. Third is two plane. One plane is this one and one plane is this one, and each plane has one OH bond pair, like in this case OH and in this case O. And angle between this is, angle between each plane is 90.2 degree. So this is some structural information regarding H2O2. Let's talk about the properties. So it can act as an oxidizing and reducing agent both. This is the beauty of this compound. It can act as an oxidizing and reducing agent both. I will give only one or two equation. Okay, you can go or you can refer any book for the detailed reaction, but I will just give you one or two reaction. So for oxidizing agent, let's start the reaction. Ki, potassium iodide, with H2O2, this will give KOH and I2. So here potassium is in -1 and iodine is in -1 and iodine here is 0. So it can oxidize, because here the oxidation number is increasing, -1 to 0. So this is oxidizing Ki into iodine, so it will act as a oxidizing agent. Okay, then let's take an example of reducing agent. So the reducing agent, it can reduce O3, ozone, to oxygen. Okay, so this is how the reducing agent reaction takes place. Then the uses of H2O2. So it has many uses. Like the first is it is a bleaching agent. It is also an antiseptic agent. And it can also use as a preservatives. So bleaching agent, how it will act as a bleaching agent? Because H2O2, hydrogen peroxide, will give you H2O and oxygen. This is called Neskin oxygen. So this Neskin oxygen will color any colored substance. With combination with this Neskin oxygen is converted into colorless. So this is how it will act as a bleaching agent. And the higher concentration, if we have higher concentration of H2O2, then it will act as a propellant in rocketry. Rocketry. So it has many uses. This is few of them. Today when I was reading a newspaper, there was a news that ओजोनाइज पानी से सब्जियां सैनिटाइज की जा रही हैं, ओजोनाइज पानी से. सो दिस इज व्हाट द रीज़न, because as our nation is in a very pandemic situation of coronavirus, and we have to take care of all the vegetables, the food, the beverages we are taking. So the ozonized water is helpful to sanitize the vegetable. This is what the reason. This Neskin oxygen property of hydrogen peroxide is very useful. So this is very handy. Sodium hypochlorite is there. Earlier it is also using for the sanitizers, but for vegetable it can act very strongly. So this is all about today's discussion. We had a long discussion because we have to complete this topic in one sitting. It is a very smaller one, that is why I took only one lecture for this. And this is the all about the hydrogen peroxide. You can go for detailed reaction in your books. This I have given a brief only. Okay, so I'm going to end this discussion by one question. Just write your answer in the comment box. Why H2O2 is stored, why H2O2 is stored in plastic container, plastic container. So this is the question of this discussion. Why H2O2, hydrogen peroxide, is stored in plastic container? Just explore your books or internet and you find the answer and write the answer in the comment box, or you can directly send your answer to my WhatsApp number. So this is all about from oxygen family as per your syllabus. Okay, we will complete the inorganic chemistry syllabus in next few lectures. I think it will take one or two, maximum 3 lectures. We have only one segment is left, that is the group 17 elements, the halogen family only. Okay, so we will complete this that is in 2 or 3 lectures. Thank you so much for your watching.